Hey everyone, today we're going to be looking at flags in C++. Now there's lots of different ways to do this, and this is only one way, but I am going to try to show some advantages that I personally see with this way, and it's up to you to decide whether or not you would like to implement it in your code. So let's just build this real quick or compile it. Make sure compiler is doing everything it should. Hello world. Great. Compiler is up and running. So let's just do a typical enum like you've probably seen 100 times. Call it enum1. I'll put in here value1. I'm going to bit shift it over 0. Value2. Value 3, we'll go up to value 4. Now, if you haven't seen this syntax before, this is the same as 1, the same as 2, same as 4, and the same as 8. So rather than having to do the powering by 2 in your head, you can just do this, and at least for me, it's easier to count than do the powers of 2. All right, so we have an enum1, call it my enum, equals value 1. And I'll just put in here an if my enum equals value 1. So this is just purely enums. We're obviously not doing flags yet because there's nothing that looks like a flag yet, and that's just to establish a baseline here. Has value 1. Does not have value 1. So has value 1. That makes sense. Let's make it look a little bit more like a flag. Instead of double equals, we'll check using the bitwise and function. And let's utilize the beauty of IntelliSense and let it actually act like an enum type, giving us these nice values. So we'll run that again. Great. Okay. So that's all fine and dandy. Let's create a display enum function. Build the prototype real quick. Just cut and paste this. And let's call it. Obviously expecting that to work. Let us try this once. Let's use a bitwise OR and try to do this. Has value 1. So everything up to this point is working just the way you would want a flag to work. Now, if we don't have this, obviously, it's not happy with us. And I can show you the compiler error. It says that you're converting from an int to an enum. I knew that before I did it, so we just have a C-style cast here. And if you are specific about your castings in C++, like I'm sure many of you are, you can just do static cast. Static cast is the one you're looking for. Everything compiles again. All right, well, yeah, this works fine. This isn't an issue until you want to do another enum. And let's say that you want to also use value 1. For some reason, this is important. And let's set it to, I don't know, 10. And we'll do value 2 equal to 20. And let's build it. We saw that coming. So the issue we have here is that value 1 is conflicting with a previous declaration. And if we get rid of enum 1, really getting my refactoring time in here. All right. Everything's fine again. So obviously enum 1 and enum 2 both had value 1, and that was an issue because they were different amounts and you're redeclaring it, and it's just you can't do it. It's a limitation. But to try to do something, let's try using my enum instead. And I'm doing this in the wrong spot. We're going to be smart this time. Just going to replace all. Well, that was easy. We're going to use my enum, and we have value 1, value 2, and this my enum's actually been here this entire time because it's coming from scoped enum HPP. And just to prove that conflicting values are not an issue, it still builds. So, how does this work? How does this act like a regular enum, but it gets rid of the issue that we have with redefining? And that's basically what this entire thing has been about, trying to find a way to do that. So let's look at what's going on. We have created an enum called my enum. It looks very much like enum 1 did, except it's inside of a namespace. And you're probably thinking, oh, well, that's obvious, because if it's in a namespace, that means that this value 1 and this value 1 will not conflict with each other. But how did we do it so that we could use my enum this way? And if you were watching carefully, you probably saw the solution. And that is this using statement. So using is kind of like typedef, except the order is reversed and there's an equal sign. Personally, I like this because I think it's very clear what you're doing, but they basically mean exactly the same thing. There are some minor differences buried behind the scenes that you can find, but that's it. That's what's happening. We have our my enum, and we wrap it in this, or we create a type called this so that it is easier to use going forward, and you don't have to include the namespace every single time. You don't have to put in a bunch of using namespace, my enum, ns, and if you had 100 enums, you would be doing that 100 times, or you would be having to put my enum ns here, colon, colon, every single time. So it allows you to write your code in a very easy, clean manner, and it gets rid of the problems they can run into. Now you might be thinking, why don't you just use enum class? Enum class is great. However, it is not designed for flags, and that's exactly what we're doing here. And here is we're working with flags, and there's really no way around it. You can add an operator overload. I mean, you can do it. You could do it with templates or something, but you're talking about, well, let's put it down to it. You're talking about work. You're adding more lines of code to adjust for it, and every time you create a new enum, you're going to be adding those lines of code to make that enum work. Whereas this kind of works out of the box, and it's very, it's if you exclude curly braces, because some people put these on the same lines anyway, it's one extra line of code here and one extra line of code here. So basically it's 2 extra lines of code. Now I know somebody's going to say, well, this curly brace is here. Fine, 3. It's between 2 and 3 lines of extra code that you have to add. You're not adding a function every single time to make it work. Or you're not dealing with a template trying to cast it for you or anything like that. It's fairly straightforward. But anyway, if you like this, go ahead and use it. I have found that I personally like using it, and I hope that this video has helped you and that you enjoyed it. And also, please subscribe, and if you like this video, like it as well. That helps with the YouTube algorithm. All right, thank you. See you next time.